Hi, I'm Jeremy Hess with Akeyless, and in this video, we're going to show you how to use external secrets operator to fetch a secret from Akeyless and store it as a Kubernetes secret in your cluster. External Secrets Operator, ESO, is an open source project that makes it easy for users to fetch secrets from external secrets management tools and inject them into etcd as Kubernetes secrets. Many organizations have already put in a lot of effort to work with Kubernetes secrets for their current environment and don't want to change their workflows, which can be anything from updating small components within automation to large-scale refactoring of code. With ESO and Akeyless, organizations that are already using Kubernetes secrets will have a more secure method for storing and managing the full lifecycle of their secrets with strong encryption. So let's go ahead and see how it's already. So getting started, we're going to go ahead, of course, to our docs page for the external secrets operator. And before we get started, we're going to make two notes. The minimum supported version of Kubernetes for this is 1.16 in order to install external secrets. And you also need to have Helm installed to go ahead and add the repo and install external secrets. So we're going to go ahead and run the first command to install the repository. Okay, we've added the repository. And the next thing we're going to do is install external secrets onto our cluster in the default namespace. Once that's installed, we'll go ahead and add our next resource, the secret store resource, which creates a access and authentication for the external secrets operator to Akeyless. So what we're going to do is there are two options. The first option is to have a credential created for us to use that for authentication. But since we already have Kubernetes authentication ready for us, which we did in a previous video, we're going to use that Kubernetes authentication to authenticate to Akeyless in order to grab the secret from Akeyless. So let's go ahead and do that now. So in order to do that, we're going to go ahead and grab this piece of code here. And what we're going to do is actually create a file on our machine. We'll call it K8s secretstore.yaml. And we're going to go ahead and paste this information in. And we have to make a few changes here to the information. So first, we're going to go ahead and put in our gateway API URL. And I'm going to go ahead and paste it in. And what we want to make sure to do is we're using port 8080 and v2. Okay, so the next thing we're going to go ahead and do is add the access ID here. So if we go ahead into our auth methods in our console, we grab the access ID, paste it in there. And the last thing we're going to do is add our Kubernetes configuration, which we already created in the previous video on our gateway. And the last thing we have here is a service account reference to authenticate with the JOT for this specific service account. So we're going to go ahead and create a service account called mySA in the namespace that we want to use. So go ahead and save that. The next thing we're going to go ahead and do is actually create our new namespace and the service account within that namespace. So let's go ahead and run kubectl create namespace. We'll call it Jeremy. Great. And let's go ahead and create our service account. So kubectl create service account. We'll call it mySA as we showed in the file. And we're going to put it in the namespace Jeremy. Now we have all that created. What we're going to do is run kubectl apply on our K8s secret store YAML file. So let's run kubectl apply -f K8s secretstore.yaml and in the new namespace as well. Now we have the secret store resource created. One other piece of information here that we're going to add is within our access rules, what we want to do is give the minimum amount of permissions to the user in order to show how we can use role-based access and use tight permissions and permission controls. So for this auth method, what we're going to go ahead and do is edit the subclaim, and we're going to write namespace equals Jeremy. And this will enforce that only in this namespace will we be allowed to do any of these actions, including grabbing the secret. So the next thing we want to go ahead and do is head back to our docs, and we're going to create the external secret resource, which is actually going to then pull the secret from Akeyless into our Kubernetes cluster. So let's go ahead and run vi, we'll call it external secret.yaml, paste in that bit of code. And what we're going to do is just go over this quickly. We see that we are referencing the Akeyless secret store, which we created earlier. Our target is the name of the secret that's going to be created in etcd in the Kubernetes cluster. It's going to be called Akeyless secret to create. And the last thing we want to do is add the path to the actual secret from our Akeyless account that's actually going to be used to be pulled into Kubernetes. So if we go ahead back to our secrets and keys, let's grab, for example, this static secret, my first secret. If you click on the three dots, copy static secret full name. This will include the path as well. You just paste it in there, and we're going to go ahead and save that and quit. And the next thing we're going to run is kubectl apply -f external secret.yaml in the namespace Jeremy, and this is going to go ahead and pull that secret for us. Now that that's done, the last thing we need to do is just show that it worked. So how do we see that it worked? We go ahead and use this little piece of code. kubectl get secret Akeyless secret to create is the name of the secret within Kubernetes. We will make sure we are in the correct namespace. We hit enter, and there is that value. And now let's go ahead and see an example of what happens if we do the same thing, but if we try it in the default namespace. So if we want to go ahead and see how this would work or wouldn't work if we try to do this on the default namespace, again, we use the subclaim namespace equals Jeremy, and of course we need to use the my SA service account as well. So if we don't have those on the default account, let's see what would happen if we ran the same thing where we installed the secret store on the default namespace, and then we went ahead and tried to apply external secret on the default namespace as well. If we go ahead and run the same command within the default namespace, we hit enter, you'll notice that there's an error and we're not able to find that secret because it was not pulled in from Akeyless, as there were not the correct permissions from that namespace. So that is how you use external secrets operator with Akeyless. Thanks so much for watching, and see you in the next video.